Hello viewers, welcome back to my channel. In this video I am discussing some important questions of real analysis. Okay, this is the second video I am discussing important questions of real analysis. Okay, the first question is the limit extends to 0 1 by x integration of x to 2x e power of minus t square dt, and they given four options. This is the question asked in CSIR net 2015. Okay, this is very important problem. Usually this type of problems asked in IIT JAM examination and Kset and as well as many other higher mathematics examinations. Okay, option A is does not exist, and option B is infinite, option C is exist and equal to 1, and option D is exist and equal to 0. Okay, now we have to solve this problem. The solution for this question is limit x tends to 0. I am this written in like this: x power up to integration x to 2x e power of minus t square dt by x. I am written this problem like this also. Okay, we apply the limit, we get 0 by 0 form. Okay, here x value 0, here x value 0, that means this numerator 0 and denominator also 0. We get 0 by 0 form. Now we have to apply the L'Hospital rule. Okay, differentiate separately numerator and denominator. Limit x tends to 0 d by dx of integration of x to 2x e power of minus t square dx dt by d by dx of x. Okay, we get like this. Okay, now we have to apply the Lignit's rule. Here we apply the Lignit's rule. Okay, limit extends to 0. Okay, in place of t we take 2x e power of minus 2x whole square, and differentiate this, differentiate 2x, we get 2 minus, again we take in place of t x, we get e power of minus x square, and differentiate x, we get 1. This is the rule, Lignit's rule, and denominator differentiation of x is 1 only. Okay, we solve this. Limit x tends to 0 e power of minus 4x square to e power of minus 4x square minus e power of minus x square. We apply the limit here, we get limit x tends to 0, 2 into, we apply the limit directly. In place of x we take 0, we get e power of minus 0 is 0, e power of 0 is 1, 2 minus here 1, we get 2 minus 1 is 1, we get the limit value is 1. Therefore the correct option is the limit exists and equal to 1. This is the correct option. Okay, we move on to next problem. Consider the improper Riemann integral. Riemann integral, integration 0 to x y power of minus 1 by 2 dy. Okay, the integral is this is the problem asked on CSIR net 2016. Option A is continuous in close 0 to infinity, and option B is continuous only in open 0 to infinity. Option C is discontinuous in open 0 to infinity, and option D is discontinuous only in open 1 by 2 comma infinity. Now we have to find the integration value of this. Okay, I is equal to integration 0 to x y power of minus 1 by 2 dy. We directly, now we have to directly integrate this. Okay, we apply the integration of y power of minus 1 by 2 plus 1 by minus 1 by 2 plus 1, limits are 0 to x. Okay, this is equal to y power of 1 by 2 into 2, we get like this, 2 y power of 1 by 2. Okay, and we apply the limit 0 to x, so that's equal to 2 root of x. Okay, 2 root x, we get like this, 2 root x. Then we observe that this is root is defined only for positive values, and now we have to observe here this is the correct option, continuous in close 0 to infinity. 0 also define in root. Okay, we take 0 1 2 3 like this, we take any value this satisfies, therefore the correct option is option A is the correct option. Now next we move on to next problem. Which of the following are null sequences? Null sequence means the sequence value is 0. Okay, the sequence value is or limit value is 0. Okay, option A is n by alpha 4 of n, alpha greater than 0 greater than 1. Suppose I am take alpha is equal to 2, n by 2 power of n. We get like this the limit. We take limit n tends to infinity. We directly apply the limit here. We get infinity by infinity form. Then differentiate numerator and denominator separately. We get 1 by 2 power of n into log 2. Okay, differentiation of 2 power of n is 2 power of n into log 2. We apply the limit n tends to infinity. We get 0. Okay, therefore the correct option A is correct. Okay, then we come to option B. We apply the limit n tends to infinity. We get here also infinity by infinity form. Then differentiate separately. We get 1 by n by 1. We apply the limit n tends to infinity. Here also we get 0. Therefore option B also correct. Okay, option C is all power of n, the sequence all power of n, where mod alpha is less than 1. Mod alpha is less than 1. That means we know that one of the result, we apply the limit n tends to infinity all power of n. That implies if 0, mod alpha is less than 1. Okay, 1 if alpha is equal to 1, and infinity if alpha greater than 1. This is the one of the result. We know that. Okay, by this result this is 0. The limit value of this is 0. Okay, therefore this is also correct option. And option D is 1 plus 3 by n whole power of n. We apply the limit n tends to infinity. We get 1 power of infinity form. Then I am giving a trick for this. Okay, the trick is we directly take e4 of f of x. This is if we get 1/4 of infinity form, the given problem is in the form of like this, limit n tends to infinity f of n whole power of g of n is in the form of like this. Then the trick is a4 of f of n minus 1 into g of n. Okay, here n is there, that's why I am taking n. Okay, if they are given x, we take x. Okay, e4 of f of n minus 1 g of n. Then e4 of f of n value is this is 1 plus 3 by n minus 1 into g of n is n. Okay, this cancel, this cancel. Okay, we get e cube. We get directly e cube, but this is not equal to 0. Therefore this is incorrect option. Okay, then we move on to next problem. Let a sequence an be a sequence of real numbers defined as this is the sequence they given. An is equal to -1 by n, and n is even, and n plus 1 by n if n is odd. Then which of the following is correct? Okay, which of the following is correct? Option A is the given sequence n is oscillator. If we apply the limit n tends to infinity, we get -1, and we apply the limit n tends to infinity, we get 1. Therefore we get different values. This is oscillate between the sequence oscillate between -1 and 1. Therefore the option A is the correct option. And second option is if limit limit inferior of an is equal to a and limit superior of an is equal to b, then an is equal to ab is equal to -1 for all n belongs to n. If this is correct statement or not, we have to check. What is the limit inferior? The limit inferior means smallest limit point we called as a limit inferior. Remember this trick. The smallest limit point we call as limit inferior, and limit superior is the greatest limit point. Greatest limit point is called limit superior. Okay, here we have, after applying limit n tends to infinity, we get the smallest value is -1 and greatest value is 1. Okay, therefore the a value is -1 and b is equal to 1 we get. Okay, therefore an is equal to ab, means -1 into 1 we get -1. Therefore this is the correct option. Okay, and C option is n is properly divergent. They tell that the n is properly divergent. What is properly divergent? Now we have to see the divergent definition. Divergent is divided into two parts, that is proper divergent and improper divergent. Proper divergent means it is diverges to infinity or diverges to minus infinity. This is called as a proper divergent. And here improper divergence means it is diverges to oscillately finitely and oscillately infinitely. This is we call as improper divergent, but after applying limit we get oscillatory, but this is not we not get any infinite value, therefore this is wrong option, and this is also wrong. Okay, like this we solve the this problem. I hope you like this video. If you like this video, please like, share and subscribe my channel. Thank you. In next video I am come with very interesting problems. Thank you.